In this video, we'll be talking about the concept of regulation for digital electronics. Why do we need to actually regulate things? What are we regulating, and how do we actually do that regulation? Well, first question before we actually start about regulators is what digital voltages are present in our circuit? So it may be like 0 and 5 volts are the two voltages we're dealing with. It may be 0 and 3.3 volts, or there might be 0 and 3.3 and 5 volts, or maybe even something else as well. Different systems within the same circuit may use different voltages. I've used one camera interface with a microcontroller, and that had 3.3 volts and 1.8 volts, and I think 2.7 volts, and needed 3 different regulators for each one. Well, what's our supply voltage is the next question. Are we using a plug pack, one of those things you plug into the wall that gives you 12 volts or 9 volts or whatever it is? Are we using a bunch of sets of AA batteries to give you maybe 3 volts or 4.5 volts or 9 volts or whatever it is, depending on how much we use? Or we're using some of those 18650 lithium cells, which give us 3.7 volts, or nominal 3.7 volts, but when you charge them up, they give you about 4.1 or 4.2 volts. There's a lot of variables and a lot of different voltages that we could be dealing with. The voltage regulators then allow us to regulate to a stable voltage and something that's fixed and we know where it is. So the voltage regulators allow us to regulate to a stable voltage. Basically, they take one DC voltage, and that voltage may change over time. It may just go down slowly over time, or there may be some little fluctuations in it. And we change it to something that's essentially a fixed voltage, something that doesn't move, as shown in the diagrams above. And the idea is they do this automatically, so we don't need to keep on adjusting things. We don't need a potentiometer and we keep changing it all the time. When the input voltage changes, we need to change something to change the output voltage. It'll do it by itself automatically. And we should note there that our digital voltages, or digital electronics, likes nice stable voltages. So it doesn't like these fluctuations going up and down all the time. We want to try and eliminate those as much as possible. So now we're going to go into some key points that we need to consider before we actually dive in onto some actual voltage regulators. First one is, do we need to drop the voltage down, so our input voltage is a higher voltage and we go to a lower voltage, or do we want to build the voltage up? And there's different voltage regulators. For example, a buck or a linear regulator will allow us to drop the voltage to a lower voltage, or a boost regulator will allow us to boost the voltage up to a higher voltage. Both of those are possible. Next one's efficiency. So we've got different types and topologies of regulators. Some are very efficient. So switch regulators are typically better than 80 or 90% efficient. But the linear regulators, it depends on what sort of voltage drop that we want between our input voltage and our output voltage. If that voltage drop is very small, they might be quite efficient. If it's very large, they might only be like 20 or 30% efficient. All the rest of that energy is going into heat and heating up the enclosure or heating up the room. So efficiency is an important thing to consider, particularly when we're running off batteries and things. Next is the current capacity. Well, what sort of current do we need? And what's our peak current that we need? Are we doing something that we're only dealing with 50 milliamps or something? Do we have a spike that normally it will run at 100 milliamps, but there's times when it will run up to an amp or something like that? We need to deal with that maximum load capacity that the regulator can support. Next is EMI, or electromagnetic interference. So our switch regulators produce a lot more switching noise because they're switching large currents very, very quickly. We need to very carefully lay out a PCB, and there's some applications where we want to remove all EMI as much as possible. And so there we wouldn't use one of those switch regulators, which tends to be a bit noisier. And finally, the dropout. So a lot of traditional regulators like the LM317, LM350, they've got a reasonably large voltage dropout. So the input voltage needs to be at least maybe 1.5 or 2 volts greater than the desired output voltage. Some ones which LDO, low dropout regulators, have much smaller dropouts, maybe under half a volt, and some of them are even smaller than that. So that's something that we need to consider in terms of what our input voltage is, or our minimum input voltage, and what our desired output voltage will be.